1,000 years from now. I think it's just, it's probably a lot to do with the fact that most people in the past didn't get good diet. They ate what they could. But today we're kind of overabundance of food, and especially when you're young, when you're growing, that would be important. Okay, so what I'm going to do right now is we're going to share a page to show you the kind of questions that you get from 9.3. So I'm assuming, but there we go. Are you lot looking at homework math 146 section 9.3 homework and a little baby calculator to the right of it? Is that what you can see?
Yeah.
Good, okay. So let's, this is question 1. The median undergraduate GPA for students accepted at a random sample of 20 medical schools in the country was taken. The mean GPA for these accepted students was 3.65. And if any of you are trying to get into the nursing program, you know that it's very hard to get in unless you've got a good GPA. So this is the same kind of thing. So 20 medical schools, and they got 3.65 as the average, and the standard error, which is essentially the standard deviation of the distribution, is 0.06. And then they go in and tell you it's basically normal. So it's a nice, evenly balanced curve. So the first question is, decide which of the following statements is worded correctly for the confidence interval, and then fill in the blanks to correctly worded one, and explain the errors and some other stuff. Right, so what I'm using is this question here. So the sample was quite small, it was 20. In this sample, the mean was 3.65, and what they're calling as the standard error is 0.06. I would like to make a 95% confidence interval. So I'm going to show you how you would do that in the calculator. So this is the, hopefully you can see the calculator. Can you see it here? My little mouse is moving around. Can you see a calculator?
Yes, sir.
Okay, good. So,
Yes.
Right, so here we go. Let's see if I can remember where it is. I'm going to hit start button. I'm going over to tests, and then I'm going to scroll down, and I'm going to go to this guy called T interval, just below Z interval. Now, when I hit it, it gives me a choice. Is the input going to be data, or is it going to be statistics? It's statistics. So when I hit enter, it now changes, and it says, okay, what was the mean? Well, the mean in this particular question was 3.65. Then says, what was the standard error? What's SX is for? In this case, it was 0.06. N equals how many people were in your sample? There were 20 places in my sample. And then you can change this number to the classic 3. 0.90 is for a 90% confidence interval. 0.95 is for a 95% confidence interval, and 0.99 is for a 99%. So if you type in 0.99, and then you can hit calculate. And I'm writing this thing down. It's 3.611 to 3.688.
Professor?
Yes.
The question said 95%.
Okay, was my question set up as 95? I thought it was. Let me check if I made a mistake.
I think you did 99.
Uh-oh. Well caught, you are right. See that? Yeah, easy to fix. It's going to be a slightly different number because of that. In fact, the number's now going to be 3.6219. I put all the data in then. 3.6781, And that is for a 95% confidence interval. And the other one is 99%. So what we can say based on the information that we've got for this very small sample, we can make a prediction, a 95% confidence prediction, that the GPA for normal medical schools for you to join, to be able to get in, is somewhere between 3.6 and a bit, 3.62 say, and 3.67. That's a very narrow window. So now we have to pick A, B, or C. And that gives us an extra place, because we could get the right numbers but have the wrong version of it. So we are 95% confident that the sample mean is between two numbers. We are 95% confident that the population mean is between two numbers. And we are 95% probability that the population mean is between two numbers. Right. When you do confidence intervals, the word that's important here is the 95% confidence. So I'm not even going to talk about C. Let's put this one in. So if I type in what accuracy, 2 decimal places they want. So if I type in 3.62, and then on the other side, then I'll put the upper limit, which is 3.68 if you round it off. And then I'll say check answer. And it says one or more of your responses is incorrect. So let's suppose I go here and I go 3.62 and I go 3.68 and I go check it. Hey, not many do that. Okay, let's see what I screwed up.
.78, not 3.68.
Oh, okay, I can't count or I can't read, but the question was correct. Okay, so, God, that's fun. I'm going for the sympathy vote here. I only have one eye. I can't see out my second eye. And this writing is not that big. Okay, so I'm going to, oh, we got somebody else coming in. I'm going to move to the paper screen right now.
Sir, I have
yes.
a question.
Yes.
Yeah, when we calculated, it says 3.62, between 3.62 and 3.68, but
yeah.
on the answer, the correct answer is different.
I think so what I typed in is that I typed the mean in wrongly. I typed in the wrong number for the mean, and so everything was shifted to the left because of that.
Mm.
Let's check that. Did I? No, I didn't.
Yeah.
No, I didn't. I don't know what I did. I did something wrong, but I can't see it now. Okay, next example is going to work, because what I did was correct. The application of it was not. I screwed up somewhere that I can't see. So let's create a 90% confidence interval. So I'm going to create one. I have a story to go with, of course. So let's suppose that we collected a sample of 200 people. And in this sample, the average number of children that they had, so this is married people, was, well, not necessarily married, was 3.1. And we got the standard error was something like 0.2. Now, if you have those three numbers and only these three numbers, you can do pretty much everything that you could possibly want. Well, for instance, I would like to create a 90% confidence interval. So how am I going to do that? I'm going to see if it works on my calculator. If it does, then I won't need to zoom back and forward here. But I want to see if you can actually see it. All right. I don't know. Maybe. Right. Can you see the calculator here? Is it readable, or will I have to go on the other screen and show you it slowly?
It's dark.
Dark. Okay.
Dark.
It's not readable. It is what it is. So you're just going to have to bear with me as I jump back and forward here. So what I'm going to look at is this fellow over here. Okay. So calculator is on. Let's clear that guy. I'm going to go stats. I'm going to go downwards. No, I'm not. I'm going to go across first to
Sir,
tests.
can you share
Yes.
the calculator, the screen? We can
Ah,
see it.
Can you
There
see
you
it
go.
now?
There
Okay.
you go, yeah.
Right. So I'll pretend that I just started then, so you don't miss any of the buttons I pressed. So what you do is you hit stats, then you move over to tests, and then you go down to here, we'll hit interval. And we're going to do statistics again. Boom. And then I should be able to type in the new mean, which is 3.1. So it's a different question. So on average, there are 3.1 children. The error was, standard error was 0.2, and there was 200 people. And we want a 90% confidence interval. Now, all I should do now is hit calc, and we should get an answer. And the answer is somewhere between 3.08 and it could be as high as 3.12. So the type of general question that you're going to see is create that confidence interval. So we have one, and then we'll see where we can move from there. Right. So you look at this range, you could probably say, based on this information, that you're 90% confident that the average number of children is between 3.08 and 3.12, which is a very tight interval, surprisingly so. But the main reason for that was that this guy here was pretty decent sample size, and an extra reason why it's so tight is because of the standard error being small. If that standard error was 5, this interval would swell up. If that sample size was 20, this interval would swell up. Suppose I ask a different question based on this certain interval. This is the question. Are you confident that the average is greater than 3? Well, I have a confidence interval that says we believe the real answer is somewhere between these two numbers. We're 90% confident that it is. Would you agree that all of these numbers are bigger than 3? So your answer to this question, are you confident that the average is greater than 3? You would be saying, yes, I am. And the reason is because all the values in the interval are greater than 3. So that one would be, yes, I am confident. Here's another version of that question. Are you confident that the average is less than 3.5? Using only this confidence interval, are you confident that the average of all American families is less than 3.5?
Yes.
Yes. So the second part of that is very often you fill in a kind of missing words. Why are you confident? Because I agree with you, you're right. Why are you confident that it's less than 3.5?
Because the confidence interval is below 3.5.
Yeah, because all of these numbers, right, are less than 3.5. That's me just paraphrasing what you said. And there is a third one. Are you confident that the average is let's find something. It's between 2 and 3. Right, are you confident that the average number of children in the family is somewhere between 2 and 3?
No,
I agree. Again, you're right. Explain.
because it's all the numbers or the interval are greater than 2 or greater than 3.
Okay. So imagine I do a little graphic, not a very interesting one, but can you imagine that these are all the numbers in our confidence interval, right? If I draw another number line underneath it, basically what you were saying is that. Would that be correct? I'm just visualizing what you said. Is that what you were thinking?
Mm-hmm. Yes.
So everything that is in this interval here, all these numbers, none of them are in that,
None of
right?
them. Yes.
Right. So that's essentially the kind of follow-on question that you could very often expect to see. Now, the next example that I'm going to do is creating another confidence interval, because that's really what today is mostly about, for small sample size. So we don't have let's see if anybody's turned up in the last few moments. Okay, so we've got about 6 of you. Hopefully some of you can answer this. I'm going to collect a sample, but this time I'm going to collect a sample where we just have the numbers, right? So we're collecting raw data here, right? So the question that I'm going to ask, if you are willing to share, is how many siblings do you have? So what I mean by that is you count yourself. If you're an only child, the answer is 1. If you have brothers and sisters, you count yourself plus all your brothers and all your sisters. So it might be 3, right? Me and 2 brothers would be 3. You got the idea of what data I'm collecting?
Is that living and non-living?
We should really make up rules for that, shouldn't we? Because that is a good question. Let's make it living. And I guess another question is, because you may have a half brother or a half sister, at least that's what we call them back in Britain, right? I think we should count them as well, okay?
Okay, I got 2.
Right, so including yourself or yourself and 2 more?
3.
3, okay. So our first data I've got is 3. Anybody else want to share? We need at least a few numbers.
I'm the only child, so 1.
Oh, you poor thing. Okay, next.
5.
Oh, 1 as well.
Oh, another 1. Anybody else to share?
5.
Okay, and I'm 10. So I come from a really big family. So what we have here is a very small sample size, which is 6. But I'd still like to find a confidence interval. And I'm making some assumptions here, which probably aren't true. So let's write down what the rules are for when you should really use this. The first rule is that the data should be independent, right, and random. Well, independent's fine. I'm not so sure how random it is because I'm only picking people from statistics class, my statistics class, but we'll let that one run, right? And then this one, rule 2, is the sample has to be big enough, which really means you shouldn't do samples smaller than 25. Can we just pretend that I did a bigger sample? Otherwise, I can't do the question. But technically speaking, I shouldn't be using this method at all with a sample size of 6. And lastly, the population has to be big. And that means it's 10 times bigger than the sample. Well, I'm sure the population of America is huge. So that one is a definite, that one's sort of a half right, half wrong, and that one was wrong. But for the argument for this story, we'll pretend that it passed the test, right? It's called the central limit theorem, the same one that you used when you did proportions. So it's time for me to create, oh, are you looking at the calculator right now or the white screen?
White screen.
White
Okay.
screen.
So good. So you've seen me write all this stuff down, which would make a lot more sense. Right, so I'm now going to switch over and do the bigger calculator. And I'm going to show you how you use your calculator to collect or to create confidence intervals. Because one of the things you end up doing is finding confidence intervals in quite a few questions. So here we go. Clear this out of the way. Oh. Second quit. Second quit. There we go. Clear. Clear. Is this gone now? Finally gone. Okay, so I'm going to hit the start button. I'll just do a little check. Which column at the top do I now move to?
Test.
Great. Now, the place I want to go to, is it on the screen or do I have to go a little bit lower to find it?
Go down.
One more. And the guy that we want is called a T-interval,
T-interval.
right? So when you're doing these questions, you make sure that you go to that one. Now, when I hit enter, it's got the old data, and now it's going to ask us, do we want to use data or statistics? And the one that we want to use is called data.
Data.
And when I hit enter, the screen's going to change because of that. And I know something I will have to go back and fix, but let's just show you what it looks like for the time being. Now, do you see how it now says list, frequency, and confidence interval, right? It has a different kind of look to it. List L1 is where you put your data. In my case, that's where I'm going to put the 6 numbers that we've got, right? So I'm going to have to go out of this and I'm going to have to type in that data. So if you hit start button again, this is a while since you've done this, go to number 1 as edit. Do you see that that's where L1 lives? That's where you put your numbers. Excuse me. We'll be back in a second. There you go. That was Maggie wanting attention, one of my dogs. Okay, so all I'm going to do now is type in 3, type in 1, type in 5, type in 1, type in 5, and I'm going to finish with 10. So what we're doing here is we're going to create a 90% confidence interval based on a sample of the numbers that we've collected. Now, since that's all the numbers in, I will then hit start button again. I will zoom over to test. I will go down to where we were a minute ago. I'm on data, good. So list L1, perfect. Frequency always 1. I want a 90% confidence interval, so that's good. I'm on calculate, I hit enter. And the interval that I get is somewhere between 1.39 and 6.9. And I might as well write it down since we've got it. The mean number was 4.17 and the standard error was 3.37 and the number of people we used was 6. So when we return, we'll have a look at what our data is trying to tell us. Can you see that that data there could be anything? In fact, I think there's 2 questions in the homework from that section where you've got whatever it is, 7 or 8 numbers, and you're going to do the same kind of thing. Right. Based on a very, very small sample, the number of siblings in your family is somewhere in the range from 1.39, the average number, 1.39 to 6.9. If you imagine a little visual here, well, you'll never get 0, you'll always get 1. So 2. 1.39 is roughly about here. And it could be all the way up to almost 7, 6.9. So any number in that interval there is where the average family size in America lies. Why is that interval so huge? Why is it so, from big to small? Why is it so wide?
Because the sample is small.
That's right. That's essentially all it is. The sample is just small.
Sir, I have a question.
Yes.
On calculator under stats, when
Uh-huh.
are we going to use the Z interval?
The Z interval,
The Z interval.
when you're told in the question that the data that you're collecting your sample from is normal in shape, then you can use Z, right? So that's it. Most questions, you can't make that assumption, or if they don't tell you, you're not allowed to make that assumption. So for most of the questions, it's going to be the one I showed you. But there might be an odd question where they tell you that the data, the population is normal in shape. And that is, that allows you to use the Z interval. If the sample size is reasonably big, which is basically about 100 or more, both intervals end up being the same thing. So it isn't too big a deal.
Okay. So mostly we're gonna use the I interval then, or
Yeah,
T
the T interval. Right, it's short for the student T interval. Right.
Okay.
I'm going to use the same data again, but I'm going to change its context to show you something. Let's go back out and in. Oh, I might have been in the right place. So are we on the white piece of paper again? Yeah.
Yeah.
Right. Let's suppose that I collected the sample mean and it was still this number, right? And the standard error was still that number, right? But I collected the data and it came from 600. And that'd be a fluke if it happened. But what I'm trying to show you is what sample size will do if everything else remains the same. So I've kept the mean the same, I've kept the standard error the same. The only thing I'm going to do is change the sample size. So let's pretend we did that same experiment with 600 people, and just by sheer good luck or fortune, we got the same mean and standard deviation. That way we're comparing like with like. So when the sample size was 6, we know that the average population is somewhere in that range. I'm about to, in a few moments anyway, do 600. Do you think that the interval is now going to be a tighter interval? The numbers are going to be closer to each other? Or do you think it's going to be even further? What do you think this effect is going to be?
I think it's gonna be closer to each other.
And that's exactly what it will be. So I think just to save time and effort, you're just going to trust me. I'm just going to go in and do it on the calculator and just tell you what the answer is. Otherwise, you'll be spending forever watching me go in and out of more than one window. So what I'm doing is I'm down to the test place. I'm going to the same window as before. This time I'm going to be using statistics because I've basically got all the numbers right. So I
Is
don't
it
need to put
under,
them in.
sorry, sir, is it under T interval again?
Yes, sticking to T interval, right? So I'm doing stats on that one. I'm typing in the 4.17 that we had. I'm typing in the 3.37 that we had. And I'm changing the sample size to 600. And it's still going to be a 90% confidence interval. And this time, if I go down to calculate, we'll see what we have. It's now changed to 3.87 and it's gone to 4.33. Basically what we predicted has happened. Do you see how this has gone bigger and this has got smaller? Do you see basically what's happening is that the interval is shrinking? So from here to here, there's roughly, I'll tell you what the range is. From the smallest to the biggest, that's from 4.33 all the way to 3.87. I'll have to do that again, I hit the wrong button. 4.33, take away 3.87. I got a range of nothing 0.46. On this, however, it's 6.9, take away 1.39. Its range was 5.51. So what that tells us in statistics is kind of obvious. Bigger samples give you more accurate information, right? They allow you to predict what the real answer is going to be in a much shorter window so that you can be still 90% confident you've got it right. But at least now it's a very small range. The real answer lives somewhere between here and here.
Sir,
Yes.
I have a question. How did you get the range? Did you just minus the upper
Yeah, I
and
just
lower?
said that, take away that.
Okay.
So hopefully I did it right. Yes, I did. So you take big, take away small, and that's the range.
Okay.
So if you're asked to create, or whatever the word is, if you're asked to find a 90 or a 95% confidence interval, are you comfortable that you now know how to do it using the calculator? Because that's really the only practical way of doing this. If you did it by hand, especially when it's a set of data, you'll go grey with the amount of buttons that you have to press and the places where you could quite easily just spend forever in a day. And just like that first one, I still don't know what I did wrong with that first one. Here we go. I'm just looking to see if I can find any specific. Okay, we got time for one last thing. I'm just going to create one off the top here. Let's see what we've got. Made up story. In 1800, the average height, HT for short, of a male was 66 inches. So we'll take that as just a given piece of information. In 2020, a random sample of 2005 males had an average height of 67 inches with the standard error of 0.5 inches. So it's going to be two parts to this question. The first one is find a 99% confidence interval from your sample.
You did good work today. I did a lot more with pictures today. I had to tell me which one he wanted, and I really worked on him using.
I can hear you talking to someone. You probably might not want that to be
I'm on the speaker. Hold
on the screen.
I'm so sorry, sir.
You're fine. Just in case you say something, I want you to be aware that we can hear you. Right, so a 99% confidence interval, and the second one is there enough evidence? So are you confident, in other words, that Americans are taller today than they were in the past? Right, so we've got everything that we need, and we've got all the data, and we're going to find a 99% confidence interval, and then we're going to see whether or not that's proving that Americans have in fact got taller. So imagine this was accurate there. Right, so don't really need that anymore. So we'll have this fella. Oh, doesn't want to stay. Good. Right, make sure it's on. Clear that out of the way. So I'm going to find the 99% confidence interval. So I'm going stats. I'm going over to tests. We're going to do the T interval, and it goes. That's fine. It is on stats. The mean was 67 inches for the sample, because it's the sample that mean that you put in. The standard error was 0.5. The number of people in the sample was 2005. And the confidence interval that I was trying to create was the 99% one, right? So we should be able to get our data from this. And the answer that we got was 66.971 to 67.029. Which is pretty impressive information if you think about it. Because what that is saying is that we're 99% confident, provided this was a good sample and representative, that Americans are somewhere between 66.98, I guess I could round it off a little bit more, 66.98 to 67.03. So that's A done. Is there enough evidence that Americans are now taller? Way back in the 1800s, you were 66 inches tall. That was your average. Is the average American taller than that now, based on this interval in front of me? So is it yes or is it no?
What is it again, sir? Can you repeat the question?
Sure. Based on this 99% confidence interval, are you confident that the Americans today are taller than they were back in the 1800s?
Yes.
I agree. And it's going to be the same kind of answer that we gave the last time I asked this type of question. Aren't all of these numbers, all of them, bigger than the 66 inches that you were back in the 1800s? You agree every single one of these numbers is bigger than 66 inches, isn't it?
Yeah.
And so you could be pretty confident, based on that, that you have evidence to prove that Americans are now taller. And this is not really a proof, but you could probably say, I think we reasonably agree that they're probably, what, an inch taller at least? You know? Isn't that interval basically saying the average American's 67 inches? So not only are they taller, they're probably an inch taller, at least based on this data.
Sir,
What would have happened? Yes.
I need the part that you use the calculator, sir, because there's two samples, the 2020 and 1800. So what did you use? Is it still the T interval?
To calculate the interval, I went and used the information from the sample, and it should always be the sample that you use. So the average height I typed in was 67, so that was X bar.
Mm-hmm.
And the standard error that I used was the sample standard error, which is 0.5. And the N that I used was the 2005 that we asked or measured their height.
Oh, so you still use the T interval, the one sample, I mean, one summary.
Yes, it's a T interval guy, and that's where you get your numbers from.